And we will also be talking about inverses. So pre-calculus is about what? Oh, it's been that long. What is this class about? Begins with F? Functions. Functions. Pre-calculus is about functions, right? So the log is the power, the sine is the y coordinate, the cosine is the x coordinate, the tangent is the y over x. Okay, all in the unit circle. Excellent. In terms of triangles, the sine is the opposite over the hypotenuse, right? Okay, good. All right, so if I'm introducing a new function, then as I mentioned before, I need to talk about the domain, the range, some applications of it, but also I need to talk about the graph. Okay? So I had made this bold claim that any trig function should be able to be written in terms of sines and cosines. I've introduced the initial graph of the sine of x as the y coordinate, and there it is. That's a wave, but we know that not every wave looks like that, right? Waves do all sorts of things, right? So what I want to do is to be able to talk about how all of these things matter, right? And so from this, when we slide these things, then from that we get all the waves that we might need, right? Right, so I'm going to add some cosines to that. And so what we want to do is ask, how do A, B, and C impact the graph of the original one, right? So the original one was sine. How is it that B is affecting what sine looks like now? How does A affect what happens to the sine? So we'll just take them one at a time. We'll see what A does to it. A is called the amplitude. Okay. Now this function we've been talking about in terms of applications, in terms of we need a function to represent cycles, repeated events, right? Cyclical behavior. The line doesn't do that. Quadratics don't do that. Exponentials don't do that. This is our function that's going to represent something that comes back around to itself, right? That repeats, right? So if I pause any of these, again, some mathematicians call these periodic functions. Let me pause it here. Let me pause A here, right? So here, you can start it wherever you want, but periodic functions means that it returns back to what it was before, right? So it like repeats over time. So whenever we have a wave function, we're going to want to know something called the amplitude. How high can it go? How low can it go? We'll want to know the period, the frequency, and we'll want to know something called the phase shift. Those are the three major things that we'll need in order to graph this. Okay. So that's the game plan today, at least for the first half of the class. How is it that if I give you one of these, how does it impact the regular sine curve? I'm going to take the sine curve, and then I'm going to introduce A, B, and C, and see how that makes the function look like this. Okay? That's the plan. Let's start with the original one. As you might expect, the rules for cosine will be exactly the same, because the cosine graph is just the sine graph shifted power 2 units. So all the stuff I'm about to say for sine also works for cosine, because one graph is just shifting the other one over by power 2 units. I'm going to take B and C out for the moment. As you know, this function is, I'm going to call this f of x. And we know that f of x represents the y coordinate. Okay. And so now, when I take A and put A on the outside of this function, it's going to affect the y coordinate. So that I'm not doing anything to the inside of this function, that means inside the parentheses, so that I'm not doing anything on the x coordinate, so I'm not moving anything left or right, or not stretching this at all in the horizontal direction. This is all about on the outside, right? So if I made A equal to 2, then all I'm doing is doubling the y coordinate. And so if I made A 5, then I'm just multiplying all the y coordinates by 5. And you might expect that that amplifies the function, right? The absolute value of a is called the amplitude. So that's our first definition. When we write a equals, this is in the class lecture. When we write, so when y equals, I'm going to write the full thing out for the moment, sine of bx plus c, when the absolute value of a is called the amplitude. Right. Now I'm going to go back for just a second and just look at this, and I want to return a back to 1 and have the regular function, and just tell you a little bit about that regular function in terms of the graph, some stuff that we already know. Y equals the sine of x. The amplitude here is 1. All right, goes up 1, down 1. The period is the distance it takes to repeat itself. What do you think that is? How long does it take for the y coordinate to repeat, to start over again? 360 degrees. I want to say it in radians. What is that in radians? 2 pi. Excellent. Right? So it's not so shocking now. 2 pi, pi is 3.1459, blah, 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 right? So 2 times that is about 6.28. So it's not so shocking that if you move 6.28 units on the x-axis, you start over again. And that's all we mean, that the period is 2 pi. The period of the resting sine function is 2 pi. This is to say that if you move 2 pi units to the right, you start over, but if you move 2 pi units to the left, it's like you're starting over again. You just repeat every 2 pi. The period is 2 pi. The period is 2 pi. The phase shift is movement left or right. I'm not moving it at all. This is the original function, so I'm not going to move it at all. Okay. Questions there? Now, did we remember our transformations from algebra? Right, so that when I do something to the inside, what does it do to the x and y coordinates? So if I multiply, so if I look at 3, the sine of x, that amplifies the y coordinate, right? You multiply all the y coordinates. Do you remember what happens when we do the sine of, we put 6x inside? You know what that does? It's going to do something to the x coordinate. The stuff on the inside does what? What impact does it have? It has the same impact or the opposite impact? On the inside, it's the opposite. Okay. So we'll see that in just a second, right? But the number on the outside, the absolute value of that number is just the amplitude. So for the one that I have up, I believe it's 3. Oh, it's 1 right now. So here, the amplitude of this one would be 3. All right. Let me put a number inside. I'm going to turn this back to 1. All right, so, and I'm going to put a b here. Okay. I'm going to slide b. All right. Now I'm going to change b to 2. All right, so now when I look at the sine of 2x, let's just look at a few values. Right, so the sine, oh, no, actually, let's do a comparison. So I'm going to throw the sine of x here. Let me put the sine of x here. And not shockingly, right, they're the same for the moment, right? And now I'm going to change the b to something else. I'm going to change the b to 2. And you explain to me what in the world happened. I'm going to change it to 2. There it is. So what happened? It shrinks it horizontally, right? So the street version is you know, something that you tell somebody at the mall is that because what happens on the inside is the opposite, then the 2 is not going to magnify the x-coordinate. It's going to cut the x-coordinate in half. It's going to cut the x-coordinate in half, right? So that means that you're shrinking horizontally, right? You're pushing stuff closer. The mathematical version is this, that when you put a 2 in there, then stuff happens twice as fast. You're speeding up the x-coordinate twice as fast, so it goes through its period faster, right? One way to see that is that here, look what happened, right? The blue function becomes 0 at, what is that? That's pi, right? The blue function becomes 0 at pi, and now the red function becomes 0 half as fast. I'm sorry, twice as fast, right? At pi over 2. So by putting a 2 inside, you're doubling the speed. You're making it go through its period faster. And as I make the b go higher, you're making it go faster, right? So that when I put it at 4, then what was once pi seconds it took to hit the x-axis, it happens at pi over 4 seconds. And so you can see that pretty easily, right? And here's how you see it, right? Because when you look at the sine of x versus the sine of 4x, then when you plug in pi here, right, the sine of pi, the y-coordinate at pi is 0. But here, when you do, what will make this 0? Well, we need the sine of something, and it's pi over 4, right? The sine of 4 times pi over 4 is the sine of pi, and that's 0. So it's like you're making it earlier that you get to do stuff. So all this stuff, all the stuff that the sine of x does happens earlier and faster when you put a 4 there. It goes through its period faster. We'll see that when we come up with a formula for the period. Whatever the period is, whatever we define it to be, it's going to be about b. The period has to do with the coefficient of x. Whatever the formula is, it has to do with the coefficient of x. Okay. So it seems like that b shrinks the period. Well, the period was 2 pi, right? The period of the normal one was 2 pi. And so b seems to affect it, and it does. The period is 2 pi over b. The period is 2 pi over b. That's the formula. I guess it's the previous page. The period is 2 pi over b. So when b was 4, it was going to repeat every pi over 2 units. Let's see if that's true. So when b is 4, we had the sine of 4x. We think this should repeat. B is 4, so the period is going to be 2 pi over 4. This graph should repeat every pi over 2 units. Let's see if that's true. Right? So here is one starting place. Here is the next one, right? Pi over 2. Pi over 2 is about, again, pi is 3.14 divided by 2 is about 1.5. 1.56, right? So here's 0. It starts repeating here about a little bit more than 1.5. So that's how you know that's the formula you use for the period. This homework's going to be pretty straightforward. We're just going to give you a bunch of trig functions and ask you what's the amplitude, what's the period, and what's the phase shift, over and over and over again. Okay. One of the things I have to show you is that you have to graph this yourself in my math lab. We'll talk about how to do that as well. Questions so far about the amplitude and the period? I'm sorry, go ahead, please.
So what's the meaning of 2 pi over b?
2 pi over b now is going to be the amount of time it takes for the red graph to repeat itself. So initially, this blue graph was repeating itself 6.28 times. That's 2 pi, which corresponds to 1 revolution around the circle, right? Now, when I change this from the sign of just x to the sign of 4x, the question is, well, how fast is this going to start repeating itself? So what you're doing is you're taking the blue graph, which repeats itself 2 pi times, and taking that 2 pi and dividing by the 4. 2 pi over 4, 2 over 4 is 1/2, so it's pi over 2. And now this is repeating every pi over 2 units. Pi over 2, pi over 2, pi over 2. Right. Thank you for your question. Still undefeated. Every question has always been useful. Okay. Other questions about this? Period. Amplitude. Let's move this thing left to right. Okay. I'm going to take out B for just a moment. Let me make that one. Well, let me leave that one. I'm going to take out B, and then we know what happens when we add C. We know what's going to happen there, don't we? Moves it what? Left or right. And on the inside is the opposite. So that if C, let me slide C, if C now moves positive, well, let me take it back to 0 for the moment. So there's the original, right? And so now when I move C positive, it moves it C units to the left, right? Of course, if I move C negative, it moves it C units to the right. Okay? Questions on that? We're going to come up with a formula for the phase shift. So that for that one, let me put it back on 0. For this one, the phase shift would just be C. The phase shift would be C, right? But if I had a B there, then B impacts that too, and then the phase shift would be C over B as well, right? If I had something in front of the B, that B also, it not only divides the period, which is 2 pi, but it also divides the phase shift. Okay. So we're all ready now. Let's summarize. So if you're given, and we can verify that, right? So if we put the B back in, right? And let's do a good one. Let's move C to 2, right? Then maybe we can see that we want to say that the phase shift is, and I think the standard form is a minus C. I think that they like using minus C. Okay, so that the phase shift is C over B. Okay, so when C is 2 and B is 4, then we're talking about 1/2. And so this is 0, right? And this one's 1/2. Shifted is 1/2 units, C over B. We'll summarize with this in a second. My math lab makes it a breeze to graph these. Here's the standard one, y equals a, the sine of bx plus c. We'll write the street version for this. A is the absolute value of a is the amplitude. Two pi over b is the period. The amount of time for it to repeat. Time to repeat. C, I'm sorry, again, the standard way is putting a minus sign here, bx minus c. It doesn't matter, but they love writing it as bx minus c. And I think it's because here we can just write this. C over b is the phase shift. The shift, the amount of the shift, left or right. And I think that the reason why they like it, you putting a minus sign there, is because when C is positive, you can just say it's been moved to the right, right? And when C is negative, you can say it's been moved to the left. Yeah.
B can be negative.
Say it again.
B can be negative.
B can be negative, that's right. And it might be for that reason the absolute value of b, right? So we'll need to look at the formula. All right, but we'll take a look at it. But if that's, I think all the ones you'll see b, it'll be positive. Because if it were negative, you can do stuff, right? Because the sign of negative b, right, you can bring the minus sign out. The cosine of something that has a negative b in front is just the same thing as a regular cosine. So you can just reduce it down to the regular sines and cosines without the b being negative. So I think the ones we give you, b is always positive. Questions about this? Let's get into my math lab and see how you would do some of these.
So we got 2 homework or 1?
It's 2.
2?
Yeah. So this one, oh, I'm here. It's about to kick me off. Determine the amplitude of the function y equals 8 sine x, and then graph it. The amplitude is 8. Questions? Here's how you graph it. Using the graphing tool, y equals 8 sine x, so they want you to graph both 8 sine x and the original. So you would click on this thing, and then one of these is the sine function and one is the cosine, and so it's that one that's the sine tool. So you click sine tool, and then if you just click on the graph, it gives you the original one. Okay? And you don't have to change that. All right? And then if you click on the sine tool again, it'll give you another one, right? But then you can change that one, right, according to these boxes. And the boxes just allow you to go ahead and put in the very important information that you need in order to graph it, right? So you have the amplitude, the period, and you can tell it whether you have flipped this thing over the x-axis or flipped it over the y-axis, or moved it, up or down or left or right. Okay. There was a letter I left out that I can put in just a moment, but that's pretty straightforward. You can also check to see whether you reflect it over the x-axis or over the y-axis. None of which I don't think you'll have. You won't have any reflections over the y-axis. Over the x-axis you will. So then this one has an amplitude of 8. And so then I change that to an 8, press enter, and then it gives the other one, right? So you have the original one, which is blue, that's the sine of x, and then the other one is 8 cosine x, and then, 8 sine x. And it's not surprising that one has been, this is 8 times the other one. And then that's it. So you save that, and then you check that, right? Negative 6 sine x, so we didn't talk about this negative sign, but we can see that when we look at, we're going to put a minus sign on the outside, right? Let's see what happens. Let's turn this one off. And then when we move this to minus 1, it flips over the x-axis. We knew that, right? That if we're going to put a minus sign on outside, that means we're going to take all the y-coordinates and change the sign. That means all the y-coordinates that were positive now become negative. All the y-coordinates that were negative become positive. You're just reflecting over the x-axis. So we're going to have to check that box, right? So for this one, so minus signs on the outside, you need to reflect over the x-axis. You just need to determine whether they only want the function. Determine the amplitude of the function negative 6. What's the amplitude?
6.
6. The absolute value of negative 6 is 6. And then they want both graphs, so then we'll motor through. We want that one, and then we want another one, and then the amplitude is 6, but we need to remark that we did reflect it over the x-axis because of the minus sign in front. We should notice that you'll be seeing waves a lot, right? And so you'll be asking the question sometimes, okay, how do you know the difference between sine and cosine? One of them goes to the origin. Which one is it? No. Sine goes to the origin. Right? Why? Because it's 0. What's the sign of 0? It's 0 for sure, right? The y-coordinate at 0 is 0, right? What's cosine at 0? 1. Right? So the cosine, that's why they have this for the cosine, because it looks like it's going to dip down at the origin or dip up. So if you see something go through the origin, it's probably sine versus cosine. Right? Now, sine goes up through the origin like x, like y equals x. And so if you see this one, that means there must be a minus sign in front of it. Right? Sine originally dips up through the origin. If you see it dipping down, it must be because there's a minus sign in front. That's super straightforward. I don't think there's anything that's going to be super crazy. The amplitude, what number's out in front? 1. Yeah, I'm going to skip some of these. Here, what's the period? 2 pi over 5. Okay. Pi, you can just type pi. I love shortcuts. Just type pi. 2 pi over b. Graph it. You simply need to put that stuff in. Right? This is a sine graph. The amplitude is 1. The period is 2 pi over 5. Press enter. And that's the only thing you're doing to it. Okay. Do they want the original? Determine the amplitude and then graph the function. So I think that's the only one it wants. It did not even want the original. So the first couple asked for the original. This one just asked for that function. Find the sine of 1 over 3, a little bit of algebra. So now I was biased. That coefficient I always made bigger than 1. So let's go back here. Again, we're doing the opposite. Let's put that back to 1. Let's put this to 0. I'm not shifting this at all. But now when I make, let's put this back to 1, right? So there's the original. Actually, let me make this positive 1. So I go back to the original function. Right? There's sine. Okay? And so now when I make b less than 1, what am I doing? I'm stretching it, right? Again, we're just doing the opposite. It takes longer. Let's make this negative 0.5. I'm sorry, 0.5. So now this is sine of 1/2 x. It takes twice as long to get to where I need to get to. It's not even on the graph. I now need to shift this over. Let's move this over. It takes me twice as long to get to 0 as it did before. Let's put the original back up. This is the sine of 1/2 x versus the sine of x. Right? So again, around 6, it takes me, right, it's 2 pi, 6.28 roughly, to get to 0. And now it takes me 12 something to get to 0. Right? So again, if you put 1/2 in front, it's the opposite effect. It takes twice as long to get to the same place. Okay. So making b less than 1 stretches it by a factor. And so this is only useful so that when you look at the graph, when we have this 1/3 here, it takes 3 times as long. It should be 3 times as wide as the original, so that you can check your answer and see that the answer you should get should be wider than what you had before. Right? But the actual work is pretty straightforward. But this is just to make sure that you know what you're doing. Again, the best of us know how to use the technology, the calculators, but they also know why stuff matters, right? Why stuff is true. They know the reasons that things happen. 2 pi over 1/3 is 2 pi divided by 1/3, 6 pi, right? Let's just make that clear. So the period here is 2 pi over b. b in this case is 1/3. 2 pi over 1/3, of course, is 2 pi times 3/1. Okay. Repeats every 6 pi units. Oh, let's do that. All right, this thing, oh, they put the 6 pi there. Let's get it. Get this thing. It's a sine curve. We'll put it down. Amplitude 5, period, is 6 pi, and we're not doing anything else to it. Okay. So it's 0 for the first time at 6 pi, and then it starts to repeat. I don't think these become bad at all. That's just, any questions about this? Looks like it's super straightforward, right? Save. Take an answer and just double check. All right. 5. Let's see here. All right, so now we're doing some phase shift stuff. Okay. Want to double check just to make sure. Question help. Do an example. Let's see what their formulas are. Amplitude, not a problem. Period. Yeah. Phase shift C over B. So it's 2 pi over B, so everything's positive. Okay. So then we've got the amplitude, no number out in front, that's 1. Period, 2 pi over 1. 2 pi. Phase shift is C over B. So let's just dissect this super carefully. Right, so all we're doing now is just matching up. We're matching up y equals a sine of bx minus c. That is how the formula is written. And now we're comparing that to this. Right. Nothing hurts for you to just take the time to write what a is. B is 1. C is what? What is it?
Negative 3 power 4.
That's why I did this one. Which one is it? Is it positive or negative?
Oh, it's positive because you already got it.
Because we already have the negative. Right, so C is 3 pi over 4 because the minus sign is built into the formula. The amplitude is the absolute value of A. The period is 2 pi over B. And then the phase shift is C over B. And you're literally just using the formulas. It's not shocking, of course, that this has moved 3 pi over 4 units to the right. And that's why they incorporated the minus sign again, because now when you look at this, it makes sense. That's 3 pi over 4 units to the right. Say it again. Yeah, so if there's nothing here, then it's a 1. Yep, that's right. Just like when there's nothing here, it's a 1. And we're just plugging that in. Phase shift is 3 pi over 4. Once you graph it, and again, you just put all that stuff in. Get a sine curve, it's right here. Lay it down, change it the way you need to, don't need to change that. The period is still 2 pi. A horizontal shift to the right, 3 pi over 4. See if it likes it. We aren't shifting it at all. Did we press enter? Did it move? It looked like it did move, right? Okay. So save that. See if it likes it. That's it. Yeah, and you just roll through all of those. I don't think that there, maybe we'll do this one and then we'll look at the other ones and see if we need to do any of them, if any of them are special. I'm gonna give you a second. Everyone just try this one. And then we can hurry up and end the discussion on this. Do that one. So we have a systematic way to do this, right? So I know my speed demons are going to want to do it all in their head, right? My math lab is unforgiving, right? Write what A is, write what B is, write what C is, write the formulas, plug in the formulas, and just put it in carefully, right? All of this is basic arithmetic, and so, yeah, at this point, the question is, do not be sloppy. Just don't be sloppy, right? A is 2, the absolute value of 2 is 2. B is 3. What's B? B is 3, I'm sorry. B is 3, you're right. B is 3. C is... What's C? C is negative pi. Okay, so it's the opposite of that. And then fill in the formulas as you need to. C is negative pi. It's just a negative whatever that is.
So we don't actually solve it. We don't actually like solve.
We're not solving anything. We're just looking at, yeah. So right now, all we're doing are the graphs, right? So we're trying to expand our notion of what waves can look like in mathematics, right? We had the basic one, and every other wave is just a movement according to these 3 things. So now we're talking about, let me just move down, yeah. We're talking about, for this example, we'll put it in purple. We're talking about A equals 2, B equals 3, C is negative pi. And so the amplitude is the absolute value of 2, which is 2. The period is 2 pi over 3, and the phase shift is negative pi all over 3, which indicates it's moving to the left. Pi over 3 units. And then you just plug that stuff in. About that. Graph it. All right, let's see if there's anything interesting on this assignment. There's 17 problems. I think they're just as straightforward as that. Let's see here what 6 looks like. I'm sorry, 7. 7 is the same. And then they start doing cosine. But it's exactly the same thing. All the formulas are exactly the same. What's the amplitude here? What's the period? Oh, what's B? What's C? What's C? 0, right? So there's nothing there. Okay. So then they ask you for cosine a couple of times. It's all the same. All the same, yeah. I'll take any questions about any of these. It's just that you're going to have to pick. So when you do this though, right? So what's the amplitude? 1/4? Right? You just need to make sure that you're picking the cosine graph. The period, what's the period? 2 pi over 3. The phase shift? Say it again? Negative 2 pi over 3. Absolutely. And so when you now graph, you just, of course, just need to make sure that you pick the cosine function, right? So you would pick this one and just fill it in. Lay it down, and then you fill that in. Right?
Can you go to one of the 2 fractions?
Sure. So now that is, but look, are there any questions about this?
Oh, no.
Okay. So then the previous one, why are you worried about that one? Which one was that?
I think it was like number 10, I think.
2 fractions. That?
Yeah.
Yeah. You're not afraid of fractions, right, brother?
Nah.
But you would like to do it? All right, so then amplitude.
Like 105, right?
the amplitude is the absolute value. So A is -1/5, that's right. The amplitude is the absolute value, so it's 1/5, right? So let's just name them. B is pi/3, C is 0, right?
Oh, that's why I ain't seen no C. I was like, well.
Oh, if you don't see a C, that means it's nothing. Yeah. Right. So then we're talking about the period being, let's just do it. The period is 2 pi over 3. What happens to the pi's?
They cancel.
They cancel out, right? So it's, what is this going to be?
2/3.
No.
It'll be 6.
It is 6, right? 2 pi divided by pi/3 is equal to 2 pi times 3 over pi, which is 6. It repeats every 6 units. Every 6 units. Phase shift is C over B. What's that going to be? 0 over pi/3, 0. You're not shifting it any units to the left or to the right. I think it's a new funky way for us to graph, it looks like. What's going on at 14? Same thing. Oh, sine x minus 4, right. So then I left off something that I had taken for granted. Let's go back here. When I think it's here. No, here. See, you're supposed to be keeping me honest with naming the pages. So this is plus D. What if I added that? What does that end up doing? Shifting it up or down, right? So the D on the outside, again, it's not inside the parentheses, so adding the D on the outside means that I'm affecting the y coordinate. Of course, if I add 10, it just shifts everything up 10. If I subtract 15, it's just everything down 15 units, right? You can imagine that that's pretty straightforward, so they don't even include it, right? But for these problems, they do. So they do have a vertical shift, so it is not a problem. Just the last few are just for vertical shifts. Sine x, we're not doing anything to the sine x, so we just hit sine x, lay it down, and then we just need to shift it down 4 units, right? -4. Right.
That's all?
That's it. Wow. Yeah. So, and this is what happens when you introduce something new, right? It's pretty easy at the beginning because we're introducing the new stuff, and in the beginning you have to talk about the basics of it, right? So that's minus 4. They might shift cosine, then they do the same thing for cosine. And then, oh, what is that? What is this function? I still not. Oh, you can do that. I've never seen this before. Or you can make this as large as you need it to make it. That's pretty nice. That's almost too big now. But okay. So then I want to take this. And now we need to figure out what this is. Okay. Now it could be tons of things, but they try not to make it too hard for us. Okay. So what we first of all need to decide is whether this is sine or cosine, and we immediately see that it goes to the origin, so it has to be sine. All right, so it's sine. So now we got a sine of bx. Okay, we got a sine of bx. I don't think they're doing any shifts. So it's just a sine of bx or a cosine. I think they said that in the directions, right? So it said in directions, we're not going to do any shifts. This one is either a sine bx or a cosine bx, right? It's either, so there's no phase shift because that would really be funky. Okay, so we concluded that it was sine because if we're not moving it left to right, then that means that the one that goes to the origin has to be sine because we didn't move it, right? So now the question is, we need a and b, right? So here's the street version. A is, of course, how high it goes up or how low it goes down, right? So what's a in this case? 2. Now, but the issue is that we know the original one goes up through x. So it's not 2, it's -2. A is -2. because this function is going down through the origin, and the original sign goes up through the origin. So this is then reflected over the x-axis. A is -2. B, the street version, is how often does this repeat?
2 pi. 4 pi, sorry.
Is it 4 pi? So if you choose to make this your starting point, which you can, you just need to see how long it takes to get back to a place like this, and it's 4 pi. Is that okay?
Question.
Yes.
So it's A is because it's going up to down and not down to up.
So yeah, because it's so the way that we read graphs is left to right, right? So we would say because it's decreasing left to right, and the original sine function is increasing left to right, then the coefficient outside has to be negative. Yeah, that's right. This makes, what does that make B? B is what? What's B? Is it? So that 1/2 would, what would half do? Double it, right? Yep, that's right. So you're doubling the period.
How do you read 1/2 on it?
That's a great question. So the period is 2 pi over b, right? Is that okay?
Yep.
All right. We see that the period is what? 4 pi is equal to 2 pi over b. It's repeating every 4 pi units. So 4 pi is the period, and it's equal to the thing I don't know, 2 pi over b, and now you're just solving for b. B goes here, 4 pi goes there, it's 1/2. So we'll do that. We'll cross multiply. So this is 4 pi over 1, right? So 4 pi times b equals 2 pi. Divide both sides by 4 pi. You get that b is 2 over 4, or 1/2. Okay. The way that you can see it just by looking is you're saying, yo, this, all right, let's do it. The normal one is 2 pi. This is twice as long. I'm doing something to the inside, so it's the opposite. So it's 1 over 2. Okay? So the normal one's 2 pi. This repeats 4 pi. This is going twice as fast. It's on the inside because it involves the x. Twice as fast means the opposite of 1 over 2. Okay? So that's the way to just do it without doing this algebra. Okay? And then I think that there's one for cosine, probably. Yeah, that's the cosine, and you do the same thing, okay? So that is the first homework. That's a good time to break. We'll break there, and we'll come back, and then we'll do inverse trig functions.
The answer would be 1/2, right? The answer is 1/2. 16.
Oh, so going back, yeah, thank you. Oh, so let's put in the answer. So then the answer is equal to -2 the sine of 1/2 x. Right? Yeah, -2. We'll come back in about, let's make it 10 minutes. Yes. Yeah. Gravity is 3. You didn't like that? Did it switch it? Oh, you didn't put the original. You didn't put sine. It wants both. Graph the function and sine. So that you've only put 3 sine x, and what's the original? So then, okay, so now you're done with this one, right? So now, let's go back and just put down sine. So the way that you put down sine is you go in and you just sine curve. Is it down there already? Oh.
Yeah, it's downstairs.
It's not there yet. Let's do this again. Wait. Oh, no. Sine curve again. We're going to have to clear. Oh, you have to click it. There you go. There's the sine and the function. You just want them both. That's all.
You go to conferences?
I do go to conferences. At some point, Usually I'll miss a class or two because of conferences, but this one's in the middle of the week. Usually they're at the end of the week. So like, I'll usually miss a Thursday or Friday, right? I got one in December that's Monday and Tuesday. So but they're rarely in the middle of the week.
You just go by yourself or like with your wife and kid?
Oh no, I go by myself, yeah, because it's work. So yeah, go ahead. Did you send me an email? Yeah. Okay, great. So I just opening this up for you. Yeah, so, oh no, this is something completely different. What is it? Oh, because I think it says, I put a due date on how long it would take you to be able to go in. I just need an email. Send me an email to just open the course up. So I think they set a time for it to close, to enter. And I'll change that. Absolutely. Did you mind?
So when is this homework? So this one works. This one works Sunday.
Oh no, this one's due next Tuesday at midnight.
Oh, okay.
Yeah. So yeah, homework wise, we've got something due this Friday at midnight. Or
This Friday?
I moved the homework.
From last week?
Yeah.
Oh, you
It
did?
was supposed to be due yesterday at midnight, and I moved it to Friday. I got this badger. Someone was just like, "Can you please move it? Please move it. Move it, please." I said, this person was texting me at 4 a.m. It was just crazy. I was just like, it's not that serious. I'm not gonna say who it was. How would you know when it was? I guess you were the one. I'm
But
sure
it
so.
wasn't 4 a.m. I don't think it was.
No, it wasn't 4 a.m. No, I'm joking. I just, I'm gonna see whether you're gonna respond to that or not. So.
It's still not working.
What? Really? That's not it?
Yeah.
I don't know which one. Do they care about the order you put it in? Why did you shift
The
this?
first one.
It looks like you moved it. It shouldn't be moving at all to the left or to the right. No, clear the whole thing. Yeah, hit that. No, hit that. Clear it. Clear. Just, we're sure. Yeah, okay, now put down sign. Yeah, hit the graph. Let's put down the original first. Click there. We're good with that. All right, and then click it again. Yeah, put it down. No. What are you doing? Click. Yeah. Hit the sign. Hit the graph. Yeah. Okay, now that's the second one, but we're going to change that one. We're going to put a 3 there. 3. And that's it. Press enter. No, press enter. Because then it makes it, and then you save it. But yeah, it shouldn't. So notice that, again, we didn't do anything to the inside of this, so there should be no left-right stuff.
So when do I next?
Oh yeah, so then next week I'm gonna bring in what looks like a practice test, and then if we agree that that looks okay, then I'll open up a practice test and the real test, and you'll have a week to 10 days.
All right.
Yeah.
The last practice test.
Yeah.
It was like 2. There was a regular practice test.
Yeah.
And there was one with examples.
Yeah, that's right.
Yeah.
So
Will this
you're-
one also have examples?
that's a good question. This one's gonna have examples. I'm not even gonna make one without examples. That was just a mistake. Yeah.
But our final, we take it here, right?
Yeah, the final is gonna be, on paper and because.
On paper? What?
Yeah, because they're going to be. I'm sorry to disappoint you, but yeah, they're like assessment questions that we have to answer by hand. That
All by hand?
I'm going to grade the whole thing. Yes. I'm gonna
Do we
grade
get like a practice test to get
Yeah, well, we get a
You've
practice.
had me before, right? You've had me one whole algebra class.
Yeah.
Yes. The answer is still yes, just like it's always been. That's
Because
right.
the last time we didn't really do the
Yeah.
hand
The what?
finals. We just did the.
Oh, that's right. That was because of the time issue. Yeah, but this time, yeah, we're doing it. There's another question over here. Okay.
Do we get a practice test too on paper?
For the no, that one I would just make my math lab problems that are similar to the ones on paper. Yeah. That one will still. The practice test will be in my math lab, but the written one will just be on paper. Okay. Let's get it. Let me actually stop